angle formula is rarely used. Power reducing formula is a key to calculus. I know those of you not going to calculus are like, why am I enduring the torture? But just think of it as you're enabling yourself to have more fun. That's all that's happening. So sine squared has something else that you can use to represent it. So if you have sine squared in an expression, that is equal to, here's something, 1 minus the cosine of 2 theta.
You're recording that.
I am. Thank you for asking, though. That's very helpful. So that's a formula. Sine squared can be represented like this using double angle. So if you have twice the angle and you need to do sine of single angle, you can use this definition. Sine squared most often is represented like this, but this is not a power reducing. 1 minus cosine squared of the same angle. So this is the one, those of you going to calculus, you will use that interchangeably. But there are times where you're given a double angle and you need to be able to express sine in terms of a single angle. So we're going to do the same practice we've been doing using that double angle, and then we'll go to the cosine one. So it might look like this. Where is my problem? Because I want to. Oh. Well, these are really identities. I don't want to do identities. I want a good one. I don't want a half angle. Silly. I mean, this is too easy and it's going to be insulting. We don't want that. Okay, well, maybe we do. See what I did there? I mean, this is just ridiculous. Ridiculous. So I'm giving you a right triangle. I'm giving you that angle is 2 times theta. That's what I'm telling you. And I'm going to tell you that this is 5 and this is 4. And I want to know what's sine squared of theta. So again, we have the double angle problem. Our triangle has 2 theta. Our expression we want has single theta. You can't just divide your answer by 2. So we have to do some other things here. First thing is you've got another way you can write sine squared theta. It's 1 minus cosine of 2 theta. That's our advantage, is we do have a way to express this when we have a double angle. The problem is I don't have what I need to do the cosine of that double angle. And double angle doesn't mean you should see it twice. It means whatever this measurement is, it's 2 times that. So if this was like 18 degrees, this angle would be 2 times 18, which is 36. So it just means 2 times theta. But I want single one here. Cosine is the adjacent over the hypotenuse. I have the opposite. So you have to find your adjacent, and then it's the same thing you've been doing, sort of. So that's the next thing we're going to do. We'll find the adjacent. A squared plus 4 squared equals 5 squared, because we have the hypotenuse this time. So make sure that's on the other side of the equal sign. So that gives us a squared equals 9. A is 3. A shortcut there. A squared plus 16 equals 25, and then subtracted 16. 25 minus 16 is how we got 9. Make sure you take the square root. So the missing side is 3. Now I can fill it into our formula. It's 1 minus the cosine is the adjacent over the hypotenuse. And then all that is over 2. Now that's gross looking. We're going to simplify it. 1 minus 3/5 We need to change that. Right, so that's just 5/5 minus 3/5. So we have 2/5 over 2. You can't leave a fraction inside a fraction, it's ridiculous. 2/5 divided by 2. If you think about it, use logic. You got 2/5. You're going to cut it in half. That's what dividing by 2 means. What do you think the answer is going to be, just using logic? You have 2/5 and you're cutting that in half. 1/5. That's what you get. But mathematically, to see that, let's scoot everybody around here. 2/5 divided by 2. When you're dividing two fractions, you flip the second one. So it's times 1/2, which gives you 2/10, or you cancel those 2's. So 1/5 is sine squared. Sine squared. And if we wanted just sine, we would take the square root of that, but we don't. That's interesting. Okay, so the most difficult part of this for you is just going to be playing with these goofy fractions. So again, we had to get a common denominator so we can combine these two. My denominator's 5, so make that 5/5. You had 2/5 in the numerator. You can use logic. 2/5, and you're cutting that in half or dividing it into 2 pieces. That's why it's 1/5. Mathematically, it's 2/5 divided by 2 over 1. And when you divide fractions, you flip the second one and multiply. Those 2's cancel, and you got 1/5. That is my power reducing formula for sine. Power reducing formula for very similar, which is weird. But cosine squared, if you have a single angle, it's 1 plus cosine of 2 theta over 2. Same thing as your sine formula, only in the sine formula you had minus here. In the cosine formula, you have a plus here. Calculus people, remember that you learned this one time. And there will be times where you have to find the derivative, and your only way you're going to get that done is to use this formula right here, because you don't want a squared and you want a single. So that's why I want to introduce it, because you will see it. So let's just do one problem with that. Let's say, okay, sine of 2 theta equals 2/7. And I want to know what's the cosine squared of theta. Okay, so this one is given to me. They gave me what the sine of 2 theta is. I want to get to the cosine squared of just single theta. So when they don't give you a triangle, you got to draw your own. So we'll do that. They didn't give me a triangle. I'll make my own, dadgummit. And since we're dealing with 2 theta, I have to put 2 theta in the corner of my little triangle, or whichever you choose 2 theta to represent. They gave you sine, which means they gave you the opposite side over the hypotenuse. Again, not drawn to scale by any stretch of the imagination. I probably should pick the other angle for my 2 theta. So, a couple things here. My definition that they want is in terms of single theta. So I can't just do, some of you might be thinking, well, why can't you just do adjacent over hypotenuse for that? Well, because I don't have that. I don't have a single angle. I have the ratio for double the angle, not single the angle. So that's why I can't just do adjacent over hypotenuse and square it, because it doesn't give you the same thing. because my angles don't match. So I do have this definition up here of 1 plus the cosine of 2 theta, which is the angle I have. So that matches. But I still need the adjacent side now. So now I can use the adjacent side so that I can finish this problem. So you've got backwards Pythagorean theorem again. A squared plus 2 squared equals 7 squared. So you're working your way through the Pythagorean theorem, and you get square root of 45 for your missing side. It's not pretty. The more you involve yourself with trig and calculus, the more you end up with not pretty numbers. These Seattle Seahawks colors are nice. Let's do some Falcons colors. That's what we need here. Okay, so I'm going to go through with my formula. 1 plus the cosine of 2 theta, which is the adjacent over the hypotenuse, all over 2. It looks gross. We're going to go step by step. I want to combine those two in the numerator. My denominator is 7, so I make that 7 over 7. And that gives me 7 plus the square root of 45 all over 7 on top. And that's divided by 2. And that's ugly. And you can't convert that to a decimal. All you can do is clean it up by doing that division. And so this part is probably the hardest part of the problem. You guys don't have trouble with the trig. It's probably the fraction that's going to kill you. There's my numerator divided by 2. So all I did from this step to this step is I wrote it, instead of a fraction, I wrote it as a division problem. That's what a fraction is, top divided by the bottom. So I wrote it like that. That makes it easier to see that it's times 1/2. Oops, I put a 2 on the bottom of this instead of 7. And then you multiply that 7 and that 2 together. So your final answer, although it's not pretty, is that thing over 14, the 7 times the 2. You can't cancel this 7 and the 14. Your brain wants to cancel those. Why can you not cancel those? Because they're connected. That plus sign glues these two together. You can't rip those apart and only cancel half of it. Okay, so that plus sign prevents you from canceling that 7 with that 14, so that's your final answer there.